Hello and welcome to our lesson on fractions and rational expressions. This is going to be from section 5.2. In this lesson, we're going to be looking at the LCMs, which stands for least common multiple, LCDs, which is the lowest common denominator, and then we're going to be looking at addition and subtraction of fractions and rational expressions. Let's get started. For our first example, problem number 1 says to find the LCM, they want me to find the least common multiple of 15 and 40. I have my own technique for finding the least common multiple. What you want to do is put both of these numbers in a little box like this, and then you want to ask yourself, what number will divide into 15 or 40, either one? And the first number I notice is 5, because these numbers end in a 5 and a 0. So I'm going to divide by 5. 5 goes into 15 3 times. 5 goes into 40 8 times. And then you go again and you say, what number will divide into 3 or 8? Either one. It doesn't have to go into both. It just has to go into one or the other. So the next number I notice is 3. By the way, these numbers that you pick out here to the side, they do need to be prime numbers. So 3 goes into 3 one time, but 3 doesn't go into 8 evenly, so I'm just going to bring the 8 down. And now that I've got one of my numbers reduced to 1, I can work on the 8. And remember I said that these numbers need to be prime numbers. So 2 goes into 8 4 times, but 2 doesn't go into 1 evenly, so the 1's going to come down. Next, 2 doesn't go into 1, but it goes into 4 2 times. And then 2 doesn't go into 1, but 2 goes into 2 one time. Now, how to know when you're done? When all of your numbers become 1s at the bottom, that's when you're done. And we want to multiply all of these prime numbers out to the left, and that will give us our LCM. So 5 times 3 is 15, 15 times 2 is 30, 30 times 2 is 60, 60 times 2 is 120. So our least common multiple is 120. That is the smallest number that 15 and 40 will both divide into evenly. Okay, so just for fun, to show you how sweet and easy my technique is, I am going to look at a couple of other techniques. One of the techniques people use is they will just look at multiples of the numbers until they find a common multiple. So they'll start with 15 and 40, and then they'll go 15 times 2 is 30, 40 times 2 is 80. And then they keep going. So 15 times 3 is 45. 40 times 3 is 120. And then I happen to know that 120 is the answer, so I'm going to stop with that guy and keep looking at multiples of 15. So 15 times 4 is 60. 15 times 5 is 75. 15 times 6 is 90. Another 15 would be 105, and another 15 would be 120. And so as soon as you reach that first number that they have a common multiple of, then that is your LCM. So that is another technique. And then another technique still is the factor tree, where people will break down 15 into factors. So 15 is 3 times 5. 40 is 2 times 20. 20 is 2 times 10. And 10 is 2 times 5. And then what they will do is they will cross out any common factors. Like here we have a common factor of 5. So we're only going to take one of those. There are no other common factors between 15 and 40. So then the numbers that are left, 3 times 2 times 2 times 2 times 5, also gives us 3 times 2 times 2 times 2 times 5, the same answer we had before. Next example, number 13, they want us to find the LCD. LCD is the lowest common denominator, which, believe it or not, corresponds to the LCM. So the LCD is the LCM for the denominators. So again, I'm going to demonstrate my technique and show you that it does work for 3 or more numbers. We're going to put our denominators in a box, and then we're going to ask ourselves, what number will divide into any of those? It doesn't have to go into all. Any of those will work, and that number needs to be prime. So I'm going to start with a 2 this time. I happen to notice they're all even. So 2 goes into 4 2 times. 2 goes into 30 15 times. 2 goes into 16 8 times. And then we're going to rinse and repeat. I notice that 2 works again. Remember that you need to use prime numbers. So we're only allowed to use primes. And the prime numbers in order from smallest to biggest would be 2, 3, 5, 7, 11, 13, so on and so forth. And you kind of need to know your prime numbers. So when you're doing this technique for finding the LCM, which in this case is also the LCD, it might be a good idea to start with the smallest prime number and then work your way up to the biggest. And use each prime number, like I'm using 2, use it until it doesn't work anymore, and then move to the next prime and the next prime until, remember, you get all the numbers to be 1s at the bottom. Okay, so moving along, 2 goes into 2 one time. 2 doesn't go into 15 evenly, so you bring it down. 2 goes into 8 4 times. And again, we're going to rinse and repeat using the 2 until it doesn't work anymore. 2 doesn't go into 1. 2 doesn't go into 15 evenly, but 2 goes into 4 2 times. And we're going to be able to use 2 one more time. 1 and 15 don't divide. 2 does. 2 goes into 2 one time. And then we're going to crank it up a notch. Now 2 doesn't work anymore, so the next prime number is 3. And 3 doesn't go into 1 evenly, but 3 goes into 15 5 times. And then 3 doesn't work anymore, so we move to the next prime, which is 5. And then 5 doesn't go into 1, but 5 goes into 5 one time. Now remember, when you get all 1s, you're done. And then you simply need to multiply all of the numbers out to the left, and that's going to give us, in this case, our LCD, our lowest common denominator. 5 times 3 is 15, 15 times 2 is 30, and 60, 120, 240. That seems awfully big, but that's what we get. The lowest common denominator is 240. So the easiest way to verify that this work is correct is probably to use a piece of technology. So I'd like to introduce you to the Microsoft Math Solver. It's math.microsoft.com. And if we scroll down a little bit under the pre-algebra section, there is an option for least common multiple. So this is going to allow us to actually type in, using the code they provide here, to find the least common multiple of, well, the 3 numbers that we have. Our numbers are 4, 30, and 16. And it's going to tell us the LCM of 4, 30, and 16 is 240. So there is technology that can help you verify these numerical LCMs and LCDs. If you're wondering if the Casio ClassWiz also has an LCM or an LCD function, unfortunately it doesn't. Our next example, number 15, wants us to find the LCM of 2 algebraic expressions. Our previous examples were numerical values. These are algebraic expressions. So what we're going to do is we're going to take our 21 and our 7. We're going to take the coefficients over here to the side and do our little technique for finding the LCM. You probably see it's 21 already, but I'm going to demonstrate the technique one more time. 3 is the first prime number that will go into either 21 or 7. 3 goes into 21 7 times. 3 doesn't go into 7, so it comes down. And then the next prime number that works is 7. 7 goes into 7 one time. When you get all 1s, you're done. Multiplying 3 times 7 does give us the 21. So 21 is the LCM for the coefficients. Now the variable part is easy. You simply take the biggest exponent of any variables they have in common. So for our LCM, the coefficient part was 21. Between the x's, the biggest power is x squared. And between the y's, the biggest power is 1. And so there's our LCM for these two algebraic expressions. Next example, number 30, here we have 3 algebraic expressions, and these are not monomials like our previous one. First we have a trinomial, a binomial, and then another binomial. So if you're going to find the LCM of algebraic expressions like this, the very first thing you need to do is factor each one completely. So to factor the first trinomial, I notice that all 3 terms have an x to the third in common. So I'm going to need to factor out the x to the third, and that will leave me with x squared minus 4x plus 4. And then if that trinomial will factor, that standard trinomial, I'll need to factor it further. So are there numbers that multiply to make 4 that add to make 4? The answer is yes, 2 and 2. And so we're going to get to factor this further. The x to the third comes down. To factor a standard trinomial, we have parentheses. We need to read the signs. They're both going to be minus. And fill in the blanks. X and x, 2 and 2. And if we want to simplify that to x minus 2 quantity squared, we can. I think I will. Let's say x to the third, x minus 2 squared, since those factors are identical. Next, we have a binomial. They have a 3 in common. So remember, when you're factoring, factor out has to come first. I got to factor out the 3 first. That's going to leave me x squared minus 4. And then the stuff inside is the difference of squares. So that's going to need to factor again. So the difference of squares has parentheses, different signs, and fill in the blanks. X and x, 2 and 2. And so now that's factored completely. And then for the last binomial, we have a common factor of 2 that we need to factor out. And that's going to leave us an x plus 2. Now that we have all of these factored completely, we're going to look at each one of these factored expressions and find the least common multiple. We're going to find the factors that they have in common, starting with the coefficients. Okay, so I noticed that I've got a coefficient of 3, a coefficient of 2. The LCM of 3 and 2 is 6. So for our LCM, we're going to start with a 6. And then I notice that I've got this monomial factor of x to the third. We're going to have to take him. What do we have in common next? Well, we have an x minus 2 squared and an x minus 2 to the first. So when you're finding the LCM, you have to take the factors that they have in common and you take the biggest power. So x minus 2 quantity squared. So what have we taken care of so far? We took care of the 3 and the 2 for the 6, the x cubed for the monomial factor, the x minus 2's have been taken care of, and then look, we have a common factor of x plus 2, both of those to the first power, so x plus 2 has to be part of our LCM. Now, once you've taken care of every factor that each one of those expressions has, and make sure that it's represented down here in your LCM, you're done. Now, for number 31, we're going to put what we've learned into practice. To add or subtract fractions, you have to have a common denominator. The least common denominator would be preferable. So we're going to be finding the LCD so that we can add or subtract fractions. Number 31 is probably the easiest one we'll do in this lesson because they already have a common denominator. Their denominators are identical, and that means that I can go ahead and add the numerators. Okay, so let's start. We have 1x plus 1x, so that's going to give me 2x. I've got a minus 2y plus 9y, which makes plus 7y. So now that I've combined all the terms in the numerator, I simply say all over the common denominator, and I'm done. Now, one thing you do need to make sure of is make sure that this fraction is reduced completely. What that means, it means if the numerator will factor such that it produces a common factor with the denominator, then you would need to reduce and simplify. Okay, so again, here with number 34, our next example, we're going to subtract fractions. Again, we have to have a common denominator, which we already do. And the only thing that you need to be aware of when you're doing subtraction with fractions is that the minus, if it's in front of a fraction, it needs to distribute to the numerator. Got that? This minus applies to every term in the numerator after it. So to subtract here, we're going to subtract our like terms. We've got 3t minus t, which is going to give us a 2t. And then we have positive 2. Now watch this. Minus a negative will make this a plus. Do you see that? This minus is going to distribute and make this minus a plus. So that would actually be 2 plus 4, which is 6. And then we can say all over our common denominator of t minus 4. Now, if you want to factor the numerator, just to make sure it won't reduce, you can. There is a common factor of 2, which will leave me a t plus 3 when I factor it out. Notice that the factors don't cancel. T plus 3 and t minus 4, those are not identical. So this step of factoring out, simply to verify that it won't reduce, is recommended but not required. So this would be an acceptable answer, and this also would be an acceptable answer. All right, for our next example here, number 41, it gets a little more exciting. Remember, to add or subtract fractions, we need a common denominator. Here, these denominators, a minus b and b minus a, those are not the same because subtraction is not commutative. So what we're going to have to do is we're going to have to somehow make the b minus a turn into an a minus b. And the way we can do that is we can simply factor out a negative. Now, if we factor out a negative here, these signs, a plus and a minus, are going to make a minus overall. So there is a built-in shortcut here that I would like to demonstrate. If your denominators are identical but opposite, what you can do is simply switch this one around and change this sign. And now that you have common denominators, you can go ahead and subtract this time. We're going to have a to the third minus b to the third all over our common denominator of a minus b. Now, if you stop there, you get partial credit because this fraction will actually reduce. Okay, if you look in the numerator, what we have is the difference of 2 cubes. And so you're going to need to know how to factor the difference of cubes. If you need a refresher on that, let's go over it. So first of all, a to the third is a times a times a. B to the third, b times b times b. And I'm writing those down because I'm going to pull from those in a second. To factor here the difference of cubes, you're going to start with parentheses. Notice the second set is a little bit wider than the first. That's because there's going to be a trinomial there. And then you're going to throw in some SOAP. SOAP for the signs. SOAP stands for same, opposite, always, positive. So the first sign is going to be the same as your problem. The next sign is opposite. The last one is always positive. SOAP is only for cubes and dirty people. Now to fill in the blanks, we're going to take one of each of these factors, an A and a B for the first two blanks, and then for the other three blanks, we're going to square, multiply, square. So take this term and square it, multiply these two together, A times B, and then square this term, B squared. And so that's how you factor the sum or difference of cubes. Now for our denominator, we have an A minus B. Notice we do have a common factor of A minus B that can cancel. And so our final answer, reduced completely, would be A squared plus AB plus B squared. All right, next example, number 43. Here we're going to add fractions. To add or subtract fractions, you have to have a common denominator. Here, these denominators are not identical. They're not even close. Y plus 4 and y minus 5. Now, to get a common denominator, to find the LCM, or in this case, the LCD, you're going to need to look for common multiples. Okay, that means that you can only find a common denominator through multiplication. So the y minus 5, what he needs the y plus 4. And whatever I do to the bottom, I have to do to the top. So we're going to multiply top and bottom by y plus 4. The y plus 4 needs the y minus 5. Whatever I do to the bottom, I have to do to the top. So we're going to multiply the top by y minus 5. And now if you look at the denominators, you're going to see they both say y minus 5, y plus 4. So now we have a common denominator. Y minus 5, y plus 4. It doesn't matter what order you put them in. And now to get the numerator, guess what we get to do? We get to do the FOIL method. Hallelujah. We get to do the FOIL method twice. Yay. All right, here we go. Let's F it up. For the first numerator, y times y gives me y squared. On the outside, we have a minus 5y. On the inside, a minus 2y. Last but not least, positive 10. Now, all of that is from the first numerator. And then remember, we have addition, so we're going to put a plus, and then we're going to F it up again. Curses, foiled again. Y times y gives me y squared on the outside, plus 4y on the inside, plus 3y. Last but not least, positive 12. And then if I go through and CLT, if I combine like terms, I'm going to have my numerator. So let's start with our y squareds. That's going to give me 2y squared. And now those are done. Next, I've got a minus 5y and a minus 2y, and a plus 4y and a plus 3y. So minus 5 and minus 2 is minus 7y. 4 and 3 is plus 7y. OMG, look out, those cancel. So I have no y term. All of those canceled out. Last but not least, we have the constant. Plus 10 plus 12 gives me a plus 22. And then if you want to factor the numerator, just to make sure that it won't reduce, it's highly recommended but not necessary unless it'll reduce. There is a common factor of 2. If I factor out a 2, it's going to give me y squared plus 22. which will not factor all over my common denominator. And so since this won't reduce, this answer is acceptable, and so is this one. Either one of those would be counted correct. All right, next example. Here we have number 49. We're going to add 3 fractions. And if you're going to find the LCD of 3 algebraic expressions, here you need to factor completely. Every denominator needs to be factored completely. So x plus 1 won't factor, but x squared minus 1 is the difference of squares. So we need to break that down, and that's going to give us x plus 1, x minus 1. And then x minus 1 won't factor. Now that every denominator is factored completely, now we can find the LCD. And the way that I think about this, treat your denominators like children, okay? You look at each one and you say, what do you need? And they all have to be treated fairly. Like if one gets a cookie, they all get a cookie. So what I notice that the middle denominator has an x plus 1 and an x minus 1. This guy's got 2 different cookies. And so what the first denominator says, he says, hey, he's got an x minus 1. I want one too. And so he gets an x minus 1. Whatever I do to the bottom, have to do to the top. Now the last denominator is looking and saying, hey, they both have an x plus 1. I want one. And so you got to give it to him. But whatever you do to the bottom, you've got to do to the top. And so now you notice that they all have the same denominators. They all have an x plus 1 and an x minus 1. And so now I can go through and add these fractions. So first things first, the common denominator, x plus 1, x minus 1. Remember, it doesn't matter what order you write those in. And to get the numerator, we're going to need to distribute. So the 4 is going to distribute, and the 3 is going to distribute. That's going to give us 4x minus 4 plus the middle numerator, x plus 2, plus 3x plus 3. Remember, the 3 and the 4 have to distribute. And then all you got to do is a little CLT. Let's combine like terms. 4x plus x plus 3x. 5, 6, that's going to be an 8x. So I have an 8x in the numerator. That takes care of the x's. And then for the constants, minus 4 plus 2 plus 3. Let's see, 2 minus 4 is minus 2. 3 minus 2 is 1. Gives me a positive 1. 8x plus 1, the numerator will not factor, and it doesn't match either one of the denominator factors, so that's going to be our final answer simplified completely. So our final answer would be 8x plus 1 over x squared minus 1. Oh, I pulled a fast one on you, didn't I? You were going, hey, wait a second, I thought that was the common denominator. Well, remember, it started off as x squared minus 1. So you can either write this as x squared minus 1, or you can express it as x plus 1 over x minus 1. Either one of those answers would be acceptable. This one, however, probably preferred. Next example, number 55. Here we go again. We're going to subtract fractions. We're going to subtract these rational expressions. And to find a common denominator, you need to factor completely. Here we have 2 standard trinomials. So you're going to need to be kind of good at factoring standard trinomials, in fact, factoring in general. For the first trinomial, if I read the signs, I can see they're both going to be minus. For the second trinomial, again, if I read the signs, I can see they're both going to be minus. And then if I fill in the blanks here for the first trinomial, I get a y and a y. I need numbers that multiply to make 10, that add and make 7. Easy enough, 5 and 2. And then for the second trinomial, Fill in the blanks. I need numbers that multiply to make 15, that add and make 8. Again, easy enough. 5 and 3. And now I need to find a common denominator. So these denominators share a factor of y minus 5, but this denominator has a y minus 2. So the other denominator says, hey, I want a y minus 2 also. And so you got to give it to him. But whatever you do to the bottom, you got to do to the top. And now the first denominator looks at the second one and says, hey, he's got a y minus 3. I want one. And so you got to give him a y minus 3. Whatever you do to the bottom, you got to do to the top. And now all three factors are represented in the common denominator. So now I can go ahead and subtract. Now I do need to point out one thing here. This minus that I previously mentioned, if it's in front of the fraction, applies to every term in the numerator. So what I highly recommend that you do, if there's a minus in front, attach it to the 2y before you distribute. That way you won't forget that the signs need to change. That's just a suggestion I make to help you make sure you don't mess the signs up. All right, so let's do the distributive property first. 3y times y is going to give me a 3y squared. 3y times negative 3 is a minus 9y. And then remember, we're distributing negative 2y times y gives me a negative 2y squared. And a negative times a negative makes a positive 4y. All over our common denominator of y minus 2, y minus 3, y minus 5. And did you hear me say it doesn't matter what order you write those in? These factors can be written in any order. Doesn't matter. Now to finish it off, I need to CLT. And let's use a little TLC when we CLT. 3y squared minus 2y squared. That's going to give us y squared. I've got a minus 9y and a plus 4y makes a minus 5y all over our common denominator. And let me tell you, if you stop here, you're going to get partial credit because this numerator can factor further. Okay, notice that both of these terms have a y, and so we can factor out the y, leaving me y minus 5, which is a common factor with the denominator. So those y minus 5s will cancel, leaving me only the y over y minus 2, y minus 3. So these fractions, when you add or subtract rational expressions, they have to be reduced to lowest terms. They have to be simplified completely to get full credit. And finally, if you were wondering when are these examples ever going to end, this is it. This is our last example for this lesson. Again, we're looking at subtraction with fractions. So we're going to need to factor the denominators completely. First, we have a standard trinomial. We also have the difference of squares. Let's F it up. Let's factor it up. For the trinomial, if I read the signs are going to be different. Fill in the blanks. I need numbers that multiply to make 3, that subtract and make positive 2. And that would be 3 minus 1 to make positive 2. For the difference of squares, the signs are always different. X and X, 3 and 3. Super easy. Now, to find the LCD. Look at the first denominator and tell me what is he missing that this guy has. Well, he's missing the x minus 3, so he needs it. But whatever I do to the bottom, I have to do to the top. Oh, and look at that. We're going to get to F it up. That's the 4-letter F word. FOIL. Now, look at the second denominator and tell me what is he missing that this guy has. He's missing the x minus 1, so he needs it. And whatever I do to the bottom, I have to do to the top. Curses. Foiled again. We're going to get to F it up twice. So many F words in math. I love it. Now then, let's foil. For the first numerator, 3x times x is going to give me 3x squared. On the outside, we have a minus 9x. On the inside, we have a minus 1x. And last but not least, negative times a negative gives me a plus 3. Now, this minus is going to need to distribute to whatever we get when we FOIL this. So when we FOIL, every one of those terms is going to become opposite because of this minus. So what I'm going to do is I'm going to F it up and change the signs on the fly. Whew, here we go. X times x, x squared, but change the sign. On the outside, we have a negative x, change the sign. On the inside, plus 4x, change the sign. Last but not least, negative times a positive makes a negative 4. Oop, change the sign. Do you understand? I'm changing the signs because of this minus here. And now if you notice what I've done, this is the first numerator and the second numerator, which I'm going to need to CLT, combine like terms, and I'm using the stacking technique, okay? A lot of techniques you can use in math to make your life easier. So what I'm going to do is I'm going to combine like terms up and down. 3x squared minus x squared gives me a 2x squared. I've got a negative 9x and a negative 1x. That's a negative 10x. I've got an x minus 4x. That's a minus 3x. Together gives me minus 13x if I combine those like terms. And last but not least, 4 and 3 is 7. All over the common denominator of x plus 3, x minus 3, x minus 1. Now what you can do is you can factor the numerator and see if it will simplify further. And to factor the numerator, since this trinomial has a lead coefficient, I'm going to use the 3R method. So many good things going on in this problem. Remember our class motto, the more work it is, the more fun we have. And you don't have any say in the class motto. All right, doing the 3R method. Remove the 2 and multiply it by the 7. So that's going to give us x squared minus 13x. 2 times 7 is 14. And then factor the standard trinomial. Read the signs. They're both going to be minus. X and x to make x squared. Numbers that multiply to make 14 and add to make 13. Numbers that multiply to make 14 and add to make 13 don't exist. So this is not going to factor. Or maybe, I don't know, maybe you're happy about that. And what that means, it means that this answer here is the final answer simplified completely. And so that's going to do it for this lesson. If you have any questions or comments about anything I've done, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.